Welcome to CDM for the month of June. I've added the agenda in the chat. It seems like we've got a couple of topics so far, maybe 3 now. I think we have enough quorum at the moment, so let's begin. The first one is around Liberator's allocant flag, long-term solution for BlueStore block detection, zero block detection. Who wants to drive this discussion?
Well, I suppose I can start just because it all kind of started with RBD big provisioning, and this is not necessarily kind of centered around a particular figs or a particular flag that is suggested, but also intended to be just a discussion around what can be expected by the consumers of the object store interface, or perhaps not even object store interface, but just the OSD ops, because after the OSD op is accepted by the OSD, things become some parts of it go through the actual object store interface that things like BlueStore implement, and some parts get munched in the do underscore OSD underscore ops function that does a lot of kind of transformation on those operations that are submitted, and there are additional details that are sometimes changed in the transaction layer before the transaction gets to the object store. This is really, what can the consumer, such as RDD or CephFS, that is just issuing Rados ops, expect in terms of data layout, in terms of like the difference between logical extents and physical extents, and in terms of how much of what is written is actually preserved. And the zero block detection is just a poster child for this, I guess. There are other things such as compression. So you can think of various other transformations that the object store might do while preserving the appearance of storing the bit pattern that was written by the user. But it turns out that these details matter, and in particular, there is this use case for thick provisioning RBD images. This is something that was added a while ago, I think in the Mimic release, or maybe even earlier than that. And it basically works by writing zeros to the image. It tries to be slightly efficient, and in that it uses the write same OSD operation instead of just sending an object-sized buffer full of zeros. So at least the zeros are not sent across the network. But up until Quincy, when the zero block detection feature was introduced, this resulted in the zeros actually be written to disk in the absence of compression, of course. The other thing, so one can argue that RBD thick provisioning has always been somewhat questionable because BlueStore compression could always get in the way, and zero block detection, it can be argued to be a form of compression. But the other thing that recently came up, and which both RBD and CFFS actually running into, is encryption. So the client-side encryption for CFFS. This is the FScript framework, and for RBD, it's something that we're doing based on Lux internally within LibRBD. And in both cases, we need to be able to distinguish between zeros that are written to the image explicitly, and the areas that weren't written at all. They're basically just holes in file system terms. And the zero block detection feature, the way it was implemented, it basically runs against that as well. So not just the fact that zeros aren't physically stored on disk, but also the fact that it basically just punches a hole in the object, and that loses the information that this bunch of zeros was explicitly written to this particular object. So I guess this is just the use cases. There are more details in the tracker, which is linked from the CDM planning page, and some questions raised there as far as the guarantees that the object store contract kind of provides to end users. Some of this is currently just based on random code comments, and some of this is just tribal knowledge. So one part of this discussion is I think we need to, if there are disagreements there, then we need to kind of identify these and document, because like I said, there is some parts of it are in the transaction class, some parts of it are comments on the object store virtual functions, some parts of it just in the OSD op layer, where the OSD ops get munched, truncates, zeros, things like that. There are some transformations that occur there that may not be obvious to everyone. And the other part is the proposed solution for the zero block detection feature. So does this make sense? I know Adam is on the call and others as well. So just at a high level, because I think I've been talking for a while now. So any questions on the basic kind of objectives here?
Well, Adam here, I do agree that we should really document somewhere what's the split between object store requirements for behavior and what is not, what is basically free for implementation detail. Currently, we don't really have it. Even some flags, hints are not really described what is the meaning. For example, for flag incompressible, it's just a hint, or it should be followed more closely.
Yep. So I'm guessing that would be one kind of action item. Is perhaps we could start by just collating always random code comments together, and also have someone just walk through the enumeration where the OSD opcodes are defined, and then for each OSD opcode, come up with a short description, explanation, and the semantics. And one example that I would just give here is, again, I think it's somewhat touched on in the tracker, is the OSD op 0 opcode. So originally this was, I think, intended to be a form of, again, efficient zeroing, so that the zeros are not transferred over the network. And this is way back, so we're talking perhaps even pre-file store days. This opcode was repurposed to be used for. So the expectation, the semantics are now the expected semantics, which RBD relies on and has been for all these years, is that it's not just that zeros, it's not just that the appearance of zeros haven't been written to the object is there, but also that the data is discarded. So the expectation is that this operation frees up space, whereas for the write zeros, for the write same operation, which we've been using for thick provisioning, the expectation is that zeros are actually written out and consume space. These are the kind of the subtle details that are not documented there. And I think we should start with OSD opcodes, since that's what the clients are exposed to, and then work our way down to the PG transaction, and the object store interface, which is, I think, Adam and other BlueStore folks are most interested in, of course. But it all starts with OSD ops, and so this needs to start there.
Yeah, I completely agree. This has caused confusion, like you just mentioned, the zero or the ops 0 has caused confusion earlier as well. And given that we are at the moment rewriting the OSD, Crimson could also benefit from it. And I think it's going to be an incremental effort, as you just mentioned. But if there are some, if there are priority-wise, there are things that we should do sooner rather than later, instead of just going bottom up. Maybe so we can start with those and identify those first. But it doesn't hurt to maybe like create an Etherpad maybe, and have all those written down and check them off as we go.
Yep, makes sense. I don't think any of this is kind of super high priority or anything, because the immediate issue was resolved by disabling zero bug detection, and clearly documenting that it is not, that it doesn't interact well with some higher level features in RBD and CephFS. So yeah, that's that as far as that is concerned, the issue is resolved. But just going forward, having that documentation in place would definitely help avoid something like that happening in the future. So the other part of this topic then is the proposed solution for this, like in particular for zero bug detection, but also I'm guessing this concerns compression as well. So what Adam and I kind of briefly talked about was adding a flag which would not be a hint. So, I mean, I still call it a hint just in the name because that's what the enumeration kind of insists on. But again, as part of documenting the OSD hops, these compressible and incompressible flags could also be documented. And then this flag, I'm calling it don't transform, but the name could be changed obviously, would be documented as not a hint, but as an actual requirement. Or we could just go ahead and rename the flags that have the word hint in them that aren't actually hints. But anyway, the semantics would be that the data buffer should reach media as is. So whether it's zeros, whether it's data that is easily compressible, no matter what what other settings are set, whether it's boost or configuration options that come from the monitor config, or whether it's whatever hints that are passed down along with somewhere along the way, this flag should just take precedence and disable all of that, and basically serve as an instruction to just take the data and write it out. There are some challenges associated with that Adam brought up. In particular, the fact that this is obviously very easy to implement for the local object store. So for a particular OSD where this write happens to be directed to, but if later on rebalancing happens in some form and the object is moved to a different OSD, that OSD might have other boost store settings, again either coming from the monitor configuration database or from the local center.conf file. So for example, that other OSD might have compression enabled, and that would take this object that was supposed to be not compressed and be written as is. It would take that object and compress it, thus changing the intention, the original intention. So this flag would need to be persisted and attached to the object and kind of travel with that object whenever that object goes. So that's, I think, the high-level issue that was identified. And yeah, at this point, I think I'll again stop talking and see what Adam and others have to say as far as whether this is feasible. And,
yeah, well, the problem, Ilya, is that actually you told everything that I could tell on the topic. I was just not sure if I assumed that we have some flags that we can carry over with Rados objects when we do a rebalance, replicator, or so on. So that could be preserved. Maybe some problem could arise with erasure coding that we will somehow strip objects to pieces. Then we should track that empty space accordingly, also as non-compressible or not transformable, so we will actually take space. But my imagination is that on the Blue Store level, it is pretty trivial to implement the feature. The most logic in handling such flag would be on OSD layer.
The general idea would be that this flag, no matter what other settings are applied, will prevent any kind of transformation in the object store layer. That's the motivation. Is my understanding correct?
Exactly. The reason for the flag is to some flag connected to object is only to be persistent across replication to different object stores. So each Blue store, basically, I imagine, would get the flag, of course, converted to object store interface, but still get the info that such object should not be deflated or reduced in size in any case.
Got it. I think at a high level it makes sense. The motivation is kind of pretty clear. In terms of adding this extra metadata to the object in terms of an extra flag, I think it should be possible. We'll have to look at the place where we need to add it. But I'm just like, in general, who's going to be the user of this flag in terms of just like, when we're writing zeros, the zero detection stuff, and who else is the user of this flag? I'm just trying to understand the amount of extra code that we'll be adding.
Right now it seems like the only user would be I believe thick provisioning feature, which is somewhat, which is a bit odd. So it might, not be worth it, just for that. But I think if, folks have other use cases for just preserving the bit pattern of exactly as it is and just writing it out to disk, that might, make more sense for those other use cases. This is just, something that we talked about. It's definitely, again, not, a high priority sort of thing, because Blue Store compression, Blue Store has supported compression, I think, for as long as RBD supported thick provisioning flag, and they've never interacted, obviously. So, well, they've never interacted well. The Blue Store compression has always kind of took precedence. It's just one of the ways that, it's just like something that came up. As far as zero block detection feature, here it concerns more, so not just the thick provisioning, but also there is this other thing that I mentioned, is that it strips, the way it's currently implemented, it strips the distinction between zeros that were explicitly written to the image, even though they may be compressed later on. So at this point we don't care about whether they're stored on disk or not, but we care about knowing whether it was the end user who just wrote a range of zeros to the object, or whether that range was never written to and it's just a hole. Right, or maybe it was written to, but then explicitly, the hole was punched explicitly. This use case comes up with when implementing compression. In particular, in the Ceph case, it hurts the most, because for RBD, given that this is a block device, we can kind of work around it, although it's not easy. The file system, given that it has to abide by the POSIX interface, at least to some extent, it has the file system user can punch holes, and those holes need to be correctly preserved. So this is where the zero block detection feature just completely breaks everything, the way it's currently implemented. So the other, if we wanted to, going forward, potentially enable it by default, because it might be useful in for some workloads, and doesn't necessarily need to be limited to just development testing in pathology. If we wanted going forward to like have the ability, have the possibility to enable it in the field. The other fix, well, and it's not the other fix, because like CephFS obviously not going to pass this don't transform flag on all operations. The fix, purely for the zero block detection feature would be to make it like to introduce the distinction between logical extents and physical extents at the object store layer, and make it so that the zero block detection feature only transforms physical extents. So like basically make it equivalent to the like make it work like fallocate system call works, and not like the fallocate system call has there is a difference between punching holes and zeroing out a range, and the difference is precisely that when you zero out a range at the logical level, the range is allocated, whereas when you punch a hole at the logical level, the range becomes deallocated. And so I think that the distinction is kind of, it's not clear how much work would it be, bringing that to BlueStore and then exposing it through the object store interface. But that's another approach well, that's the only approach that I currently see that we could take for zero block detection feature to be enabled in the wild.
I think exposing a difference between logical extents and physical extents might be problematic. I mean, the analogy, Ilya, you were using breaks down at some level in BlueStore, because even if you allocate some space for object, it's never fixed. I mean, we never do a transaction that we overwrite existing space. We always allocate new space. This is for us to provide atomicity if something happens during our write operation. So even if you have object that at some point of time is allocated continuously at some location on the media, after you rewrite it in place, some inside object size, you get it fragmented because the new parts of the object are allocated, physical extents are allocated somewhere else. So that possibly will make it very strange to make a logic that you can actually allocate extents for an object at some point of time, but then it already will walk through the media and dynamically change when an object is changing.
I don't see that being an issue for this kind of second part of the conversation, for the difference between logical extents and physical extents, because this is precisely the point of kind of making this separation apparent, right? Like CephFS would not be concerned with where with the actual on-disk layout and whether subsequent write will fragment the object, and none of it matters. All that CFFS kind of cares about is that if a particular range is written to, that when you ask for an extent map for that range with there is an OSD opcode for that. I think it's called map extents or something like that. And this is also embedded in the sparse read operation, which is when you issue a sparse read against the object, it returns it returns a list of extents essentially with the extents that are allocated. It also returns data for those extents, and the extents that are not allocated are clearly marked as not allocated. And those are logical extents, right? So that's not, the zero block detection could just skip writing zeros to disk, but as long as it maintains the record that this range was explicitly written to, that's fine, and that would fulfill the desired semantics. So I don't see how the copy on write or redirect on write, whichever best describes what BlueStore does physically. I don't see that being a problem at all.
Okay, I can agree with you. I would just need some time to basically rethink what scope of changes would be required to actually add some new flavor to logical extents. I mean, adding a flag for logical extent that it's allocated but not present, something like that.
Yes, that's precisely what is needed, and that's precisely what POSIX file systems do for doing this, for supporting fallocate functionality. So just to kind of be clear, this is completely separate from the don't transform flag, and perhaps I shouldn't. I shouldn't have kind of collated the two together. These are really kind of two different discussions and two different use cases. One is just a generic kind of don't transform anything that is probably much harder to implement, and it's not clear whether we actually have a good enough use case for it, because thick provisioned images, thick provisioned RBD images is probably not, it's just a use case that is probably not worth it. The other topic is the introduction of the flag, the introduction of a new flavor of a logical extent. And that is targeted at making the zero block detection feature be enableable in the wild, so in the field. Again, it depends on whether we think, how useful would that be. If we are fine with having this feature, just be a kind of a development, thing used just for testing and just for large scale testing in topology, then that's fine with me, and we can we can basically maintain everything as is, but I would still insist on documenting the semantics more clearly for all OSD ops going forward, because I think that's useful regardless. the actual code changes, whether it's the don't transform flag or the new logical extend flavor in BlueStore, these are completely optional, depending on how much work would be needed to implement those.
Ilya, I would like to think about that extra kind of extend in the background, but could you repeat again, because I did not really grasp what is the difference for a customer between an object that has a hole inside and object that has a hole inside, but it's allocated.
The difference comes up in encryption. In particular, just speaking about CephFS and FSCrypt, which Jeff Layden is currently bringing into CephFS. The different the issue is that at least with the FSCrypt framework, the way it is implemented, the holes even if the file is encrypted, the holes still remain they still remain holes. So if the user issues a read from a hole, they should get zeros. Whereas if the user issues a read from an encrypted region, that needs to be decrypted. And there is a corner case here of a block of a plain text block that encrypts into ciphertext that is all zeros. That's where the difference comes up, because if this is a ciphertext of all zeros, you need to decrypt those zeros before returning them to the user. Whereas if it's a hole, then that hole need not be decrypted, and the user should get zeros.
Okay, I understand.
Hopefully that wasn't okay. Okay.
I understand, but that's a more topic about not having over-aggressive zero detection. That clearly will break it if we had zero detection on each block, and there will be some infrastructure that will cut all extents, blocks being all zeros, just making holes instead of writing it down, then it will break that CephFS encryption. I understand that. But I don't see connection of that with having actual hole made by some action in object, like maybe zero call, and still preserving allocation for that region. That's something I don't really understand.
The preserving again, the confusion comes from the fact that I kind of collated the two topics together. The preserving bit is completely irrelevant for the encryption use case. So the preservation goes along with this don't transform flag, which I'm guessing the conclusion is that it's just not worth it. So just forget about preserving. The semantics here are just that for this new kind of logical extent, the semantics are just that BlueStore is always allowed to throw out the physical data, and if it zeros, just completely skip skip writing those, but it should not punch a hole at the logical in the logical extent. That's what it currently does, and that's what breaks the encryption use case.
Okay, I get that.
Yeah. So if instead of punching a hole, it would just mark that logical extent as with that special meaning, whether it discards data or not discards data, CephFS and RBD, as far as encryption is concerned, would not care about.
Okay.
Yeah, I think thanks for clarifying that, Ilya. I think tracking, so the summary would be the tracking zeros at the logical layer would enable us to use BlueStore block detection feature in like a real use case, RB provision images case. So I think that is more worth pursuing and checking the feasibility of, Adam, I would say, from the BlueStore aspect of things. And see how,
yes, it requires for me to check how much actual changes would be needed then to do that.
Yeah.
Yeah, and again, it's completely optional. Like if we think that the zero bug detection can stay, developer only, testing only thing, then none of this is needed.
Sure. I mean, that's why I'm asking Adam to spend some time and check the feasibility, given that this is very recent in our minds, and writing this down would be also a great start. Like, this is what we explored, and this seems not worth it. Also, is a good way to go about it.
Okay, I think that's it for this topic then. And sorry for kind of colliding the two together. It should have been two different bullet points with two different discussions. I managed
no
to
worries,
confuse
no worries.
Managed to confuse Adam a little there.
Yeah, I think finally when you explain the use cases, I think that clarified things for us. So all good. Okay, let's move on to the next topic. Use boost accumulators for stats collection. Who added this? Hey, Yuval.
Oh, hi. Yeah, I sent an email to the list a couple of days ago. I was looking to add something to the perf counters that we use, and found out that we have our own implementation of different perf counters. In the past, I've used boost accumulators for the purpose of different stats collection in systems, and it has a huge variety of stats, starting from simple things as averages, the standard deviations, going to percentiles of different types, and many other things. It's highly optimized when you're trying to collect multiple stats using the same accumulation. So, for example, you want to do the count, the average, and the standard deviation of some value. So it knows how to do that in the most efficient way, and has some advanced algorithms for doing things like percentiles, not based on histograms, but much more efficiently. So it's really a well-established and efficient library for collecting statistics. So what I was wondering is if this was ever considered, or if it makes sense to try to embed it inside our perf counters. I would probably avoid changing the perf counters API, so because there are probably tons of places in the code that touch that. But under the hood, I mean, no, it doesn't matter what action mechanisms we use, and given that we have a relatively small set of statistical collection mechanisms there, I thought that we can change the underlying mechanism to use the boost.
Anybody have any experience with post accumulators? So I don't really recall or I don't remember when we made these choices about implementing our own performance counters, but I'm not even sure we ever considered the boost ones. And clearly it sounds promising. Anybody have any context around this area on the call?
Well, boost accumulators are used to some extent in LibRBD, and it's working fine. So yeah, as long as the perf counter API is preserved, so that the the changes don't trickle down across the entire code base, then it sounds fine to me.
Okay.
Yeah,
I think
I agree. Yeah, go ahead, Casey.
I think another consideration is how we export this data to Prometheus. Are there kind of the same primitives in this accumulators library that we can just send directly to Prometheus? Or would we have to transform it somehow?
So, I mean, if you have somewhere in the code that just call like average or max or mean or whatever on the accumulator, then those are just APIs, so that would work the same. If you're actually exporting, you want to export the internal values, then the boost accumulators, I mean, the internal values are internal, but they do have a serialize and deserialize interface, and you can serialize and in our case it won't be. We just to deserialize and expose the internals in that way. So if this is the intent with the exporting to Prometheus.
Mark, you have a point about the overhead?
Oh, yeah, I was just saying that in Crimson, the process of basically sending stats to the manager, specifically PG stats, is somewhat significant in terms of overhead in the single reactor. Less of a big deal when we do multi-reactor, right? Then that workload per reactor should be less. But generally speaking, any kind of performance counters, stats collection, stats, dissemination, the more we can make that, the more efficient we can make that, the better. So I don't know how boost aggregators look compared to what we have now, but I think probably whether they're worth it lives or dies based on if they make that process more or less efficient. It is the same, I guess. Who cares? But that's my input, I guess.
So if you talk about it, it depends how complex the stats that we're collecting. If we're just collecting averages, then it's pretty much the same implementation. You have two counters, one for the sum, one for the count, and wherever you call average, you just divide them. So we pretty much the same thing. The real value from the boost accumulators, if you want to collect like on the same measurement, if you want to collect multiple stats, then they know how to optimize that in a way that you do the minimum amount of calculations for this stat. And of course, they have a much bigger variety of stats that we currently don't use. Maybe have our own implementations. If we do implement percentiles or medians or something like that using a histogram, this is a very inefficient way to do that, and they have a much better algorithm there. So if we're doing this, then there's a big win here.
Well, the question is how much, if we are talking about efficiency solely, the question is how much of penalty we are getting in the classical OSD long time ago was taking a look. I was trying to optimize the current perf counters implementation. However, I had to change the API, so this was painful. This was really painful. Finally, we haven't merged it. The PR is closed. For Crimson, I hope, I haven't checked yet, but I put a lot of hope in not needing the atomics in the sister world. This stays in contrast to what we have in the classical OSD. Okay, there is sharding of perf counters, but still atomics must be used in.
Yeah, with this regard, I don't think we're going to have a big value from the boost counters. I don't think they have a special mechanism. So yeah, that probably won't be the big win there.
Well, I was just trying to free. Actually, the proposal is free of atomics. Everything was counted locally. Every single thread was getting their own piece of memory for storing local stats. However, at the price of API change, perhaps it's possible to preserve current one. I don't know, but my recommendation would be to do everything you can to preserve the API.
Yeah, agree. Again, I don't think. Sorry.
I said that we are talking. Atakar mentioned exporters. Sistar has its own exporters for Prometheus directly from their counters. So I think we should make sure that we are doing things that match both systems, the classic and Crimson. If you take a look at Sistar's documentation regarding the counters, they have a description of how they plan to export those. I think they have the code to do that. I glanced at it a few weeks ago. I don't remember the details, but we should try not to do duplicate work there.
I think that's related to what you posted, Avan. Maybe you can sync up with Ronan and figure out what he has in terms of C-star of counters. And clearly, that's something to keep in mind because as Crimson keeps maturing, we want Classic and Crimson to be at par in terms of features and in terms of functionality. But going back to the boost accumulators thing, I think we all agree that we want the API to not change. But in terms of efficiency, like you said that it is more efficient, and it has other things like median, etc. What you mentioned, but how do we measure the efficiency? Like, do you have any thoughts on like how do we even like compare?
Well, we can do the regular benchmark, assuming that the counters are touched, right, when you just run a regular benchmark of the code and see if there's a difference. I don't suspect there'll be an improvement. Again, it depends what kind of stats we're using. If we're just using averages or summaries, I mean, there's no difference. It's the same thing. If we're going to,
if we extend that's when we probably have the gains, right?
Yes.
Instead of writing our own. Yeah.
Yes. If I mean, I can search the code and see where and why we use histograms because we have our own implementation for histogram inside the first counters. So
yes. Yeah.
It depends how we use it and where we use it. But that could be something that would improve the performance. And I mean, if in the future there'll be like, once things are available, people will use, I don't know, standard deviation, then their implementation would be, I mean, we can have the similar implementation ourselves, but if we just naively implement standard deviation, then our implementation will be less efficient. So what I'm saying is that the basic test would be to see that we don't have worse performance. That can happen because maybe we have some concurrency mechanism smartly built into our counters that we don't have in Boost. So this, but other than that, I think the win would be in giving a larger variety of stats for developers to use in an efficient way.
Yeah, I think it's a great idea and worth exploring.
Thanks.
Any more thoughts on this topic? Okay, if not, thanks you all for driving this discussion. Let's move on to the last topic. So this is about logical large-scale testing, and this is kind of related to the BlueStore zero detection feature that got added to enable large-scale testing in Tautology. There's some work that has been started by a couple of folks, I think Aishwarya and Laura, you're on the call. Do you want to briefly describe what the plan of action is?
Sure, I can start. So first off, yeah, this almost should have been the second bullet point, I guess, to expand on all of the discussion about maintaining the contract of BlueStore, and I agree with all of that moving forward. But for now, the immediate fix for BlueStore zero block detection, which the goal of that is for to use in tautology for simulating large-scale testing, that we disabled on clusters by default, but we will enable it for tautology testing, just to be clear about that immediate fix moving forward. So the goal of this BlueStore zero block detection feature is to set up a lot of daemons with limited physical hardware and simulate a large cluster without a lot of capacity or performance, or without filling up the disks. And now we have a global config option that, of course, is disabled by default, but that we can choose to enable for tautology testing. So that we can test this out. And the idea would be to extrapolate existing tests that already exist in tautology. We can develop more, but as a starting point, use existing tests and increase the number of daemons that are used. There's currently, Aishwarya, do you remember what the limit was? I remember you said it was 6, maybe?
I think per node right now we probably have 3 or 4 OSDs, so we probably want to experiment with more after turning on this feature, and also figure out, like, in the tests, how can we write zeroed objects, and Laura and I are going to work on that and figure it out so that we can make use of the zero detection change.
And thanks. And the idea would eventually be to create a new folder in the Rados suite that we can use to start creating tests for this. And right now we're working on kind of proof of concept of this idea. But that's essentially the goal there. Neha, was there anything else that you want me to go over for that?
No, I think thanks for describing the plan of action. I think I'll touch upon the motivation. It's come up multiple times, and we discussed it in CDS Reef as well. That we lack larger scale tests in tautology, and when I say larger scale tests, like Aishwarya mentioned, that most of the nodes, like in tautology, we have the concept of roles. Each node plays like a role of 3 OSDs at max. At max, we're probably 6 nodes, so we're probably doing less than 20 OSD tests at max. We want to extend that, and with this zero detection feature, we will be able to do that without filling the actual pathology machines. So also, this in light of the recent regressions and stuff, it's all the more important for us to do larger scale tests to be able to catch things that do need larger number of OSDs than just 20 OSDs or so. This is just a starting point. We'll keep updating as we go. But thank you, Laura and Aishwarya, for driving this discussion. Any questions, any thoughts on this topic? All right, I'm not hearing anything. That brings us to the end of the agenda. Yeah, go ahead.
I'll just say, for final clarity about the initial conversation about how it interacts badly with RBD CephFS features, that interaction is not going to be, disabling this feature will be the immediate fix there, and we're separating that for now, just for clarity for everybody on the call.
Yep, cool, thanks. All right, anything we want to talk about that's not on the agenda today? If not, that's it then. Thank you everybody for joining, and we'll see you at the next CDM next month. Thanks, bye.
Thank you.
Thanks.
Hey guys.
Thanks everybody.
Thank you. Bye.